Auger. I'm president of Innova Engineering. We're located here in Irvine, California, and we are a Moldex3D reseller. I'm going to start with a brief outline of what the agenda is today. So really the objective is to discuss the effects of the manufacturing process, in this case, injection molding. What are the effects of that process as we begin to move into the world of analysis, structural analysis of a plastic part? You know, the traditional FEA is really used for, initially it was developed by, you know, aerospace people back in the 60s to understand the performance of metals. And so a lot of the mentality and processes are based upon the use of or analysis of metal parts. In the world of plastic parts, there's a lot of these assumptions that were developed for analysis of metals that really don't work. So one of the objectives here is to talk about, you know, how that impacts, how the specifics of plastics affects structural results in FEA. So the traditional approach that is used for most people, or perhaps that's too generous, but for many people, when we do plastics analysis, we assume isotropic behavior. So that, in essence, means that the structural performance of the material is the same in any direction. Isotropic meaning omnidirectional. That's not true for injection molded plastic parts. So that initial assumption is, generally speaking, flawed. The reason it's used is, again, I think it was, you know, developed by the folks that are interested in analyzing metals, which it is true for the most part. But in plastics, we have a different scenario. And the injection molding process gives us a flow orientation and a transverse flow orientation. And depending on the material, it can be significant differences in material performance based upon the directionality in the mold. So we need to consider that. And so we're going to use Moldex3D to tell us a little bit more about the orientation of the material in the mold cavity. So to go a little deeper, for injection molded plastic parts, we have anisotropy, which is more prevalent in fiber-filled materials than it is unfilled materials, but to some degree, there are differences in the directionality of the part based on the molding process. So we're going to want to we're going to want to accommodate that difference, and we'll use Moldex3D to extract those outputs. We're also interested in residual stresses. Again, this would be a more designed for manufacturing category. We want to know after it comes out of the tool, if it's a polycarbonate part or some other kind of a engineering plastic, we want to understand if there's any residual stresses that are left over as part of the manufacturing process. Those are accumulative, often with field loads, so we want to make sure we understand that initial condition of the residual stress. And of course, we want to understand warpage, weld lines, and if there's any differential density as a result of the packing phase, we want to understand that because loads as well, or structural predictions as well.